So this talk is called Haircuts for Your Code, and it's about static analysis tools. So it's about how you can use them, how to get the most out of them, what exists out there, and ultimately how you can use them to kind of keep on top of the cruft that inevitably grows in a code base. So, based on just this, hands up if you know roughly what I'm going to talk about on this first slide. You can kind of guess what's going to happen, yeah. So this is a relatively well-known Python gotcha. If you have a list or a dictionary as a default argument and you don't specify something, then it's actually the same list every time you call the method. So what's happening here is, it doesn't matter how many times you call it, it's always using the same list and appending to the same list, and you end up with something that's, you know, it's unexpected, it's not exactly what you sort of hoped for. So this is something that Pylint can warn you about. If you run Pylint in your code and you do this, then Pylint will say, hey, this is a dangerous default value. So Pylint will find this and it will tell you. Now the interesting thing is that 20% of open source repositories do this. And I'll explain how I get that rather spurious statistic in a second. So even though it is a relatively well-known Python gotcha, there are still plenty of people doing it. This is another one, and this is something that I actually learned by running Pylint on my code base. I don't know if you can see if it's big enough, but essentially if you have a logging.debug call and you give it a string and you want to interpolate some variables into that string, logging.debug is smart enough. Logging.debug is smart enough to do that for you. So what happens in the first case is you interpolate the string and then pass that as an argument into logging.debug, and if your logging level is info or higher, that string just goes nowhere and you've wasted time on the interpolation. So in the second instance, you pass in the arguments to logging.debug and it'll interpolate for you if and when it needs to, which gives you a sort of... hello? Maybe it's just me. Yeah. So it'll do that for you, and that will give you a small performance boost. And this is another thing that Pylint can warn you about. And again, so 10% of repositories do this. So this is the traditional. Okay, so we're now at the point where I talk about who I am. So I created a website called landscape.io, which does static analysis as a service, I guess you could say. So it runs Pylint and a whole bunch of other tools across your code base. If you connect it up to your GitHub code, pulls the code down, runs Pylint, all these tools, and gives you kind of nice metrics and graphs, and that's where I get these statistics from. When I say 20% of repositories do this, it's 20% of the repositories that Landscape checks. And I work as a kind of software janitor at akva.org. That basically means I'm the sysadmin who's also responsible for deployment, so I'm kind of interested in build pipelines and code quality, which is another thing that, you know, this sort of talk comes out of that, and how to improve code. Yeah, so a little bit more about Landscape. Like I say, it takes your code, it runs these tools, it gives you nice graphs, measurements, and stuff like that, and tries to warn you about things. It tries to make it super easy to do static analysis, and there's about 1,800 repositories are currently using it. You may see that little health badge in the top right there. Some people have put those on their GitHub repos. You maybe see that every now and then. So why run them? I mean, obviously the two examples that I gave, but it's not just about catching errors or problems that you kind of think are fairly obvious. So it can do things like, it'll tell you if you're using a variable that hasn't been defined somewhere, or if you're importing something that you're not using. All these kind of things are relatively straightforward, but it can also teach you things like the example of the logging.debug. That was something that I learned. And it's also, it nags you about things that you know you need to fix, but you just can't be bothered right now. I mean, how many times have you seen a code base that has to do remove this temporary hack, and then you do git blame and it was written 5 years ago. So it wasn't really a temporary hack, it was a permanent hack. So having a tool that nags you about this, that reminds you that it's there, is quite nice, because even if nothing else, it just reminds you have to do something about it. And there are various tools to find dead code or copy and pasted code, the kind of things that happen by accident or just over time. You know, you sort of, your code evolves and you leave a little bit behind that you don't need anymore. These things can all be detected. And it's basically cheap. It takes 2 minutes to run on a huge code base, if that. And you can build it in as part of your build pipeline if you have a build server, or if you just run it as a Git hook. So there's no real reason not to. Pep8.py is another tool that exists, and it basically enforces the Pep8 style advisory guide thing. So this is an example of some horrible code that I wrote to prove a point. This is the sort of terrible stuff that Pep8, you know, it will give you a million warnings about this, and you can kind of enforce a style guide by telling people, okay, we're going to use this tool to do it, rather than just saying, please do it, and, you know, people then might get lazy and not do it. And yeah, so this statistic about 15% of warnings in landscape are stylistic errors is true, but also a bit meaningless because you don't know what the other errors are. But still, it's a fun statistic. Another thing you can do is, it's not so much about just checking code. One thing that happens over time is that your requirements get out of date. So you have a list of requirements in your requirements.txt, and something happens, and there's a security vulnerability, and now your code is vulnerable, and you don't notice this because it's a slightly old code base. So if you run pip list -o, it'll give you a list of all of the dependencies in your virtual environment, or your system, if that's the way you do things, that now have newer versions. And this is quite good to avoid getting your server owned. Especially, well, yeah, I mean, for those of you who follow the Rails sort of debacles, that's the kind of thing that you need to know about really, really quickly. And so running pip list-o is one thing, and there are a couple of services that will do this for you, that take your requirements to text and they email you when there's a security update or major update to libraries and so on. And then here is a huge list of other tools. At the very end, I have a slide with a link which has all this stuff, so you don't need to try and write it down, but there are oodles of tools out there. There's some really interesting ones. Pyroma is, if you're building a package that you want to put on PyPy, there are various things you should do to be a good citizen. You should have a list of classifiers, you should specify what Python versions you support, you should have a decent long description, all that kind of stuff. Pyroma will warn you about what you have and what you don't have, and sort of remind you what you should put in there. Vultr is for finding dead code, so that's quite useful. McCabe is a measurement of complexity, so how many branches you have in a functional method, and McCabe will try and sort of say, okay, you have 20 different if statements or branches in this code, it's probably worth refactoring it and trying to simplify it because it's a bit too complex. And yeah, so I won't go into all of the tools. Like I say, at the end I have a thing where you can kind of see all the stuff that I've talked about in this talk. So one thing that I often get, and people tell me about when I describe landscape or when I talk to them about static analysis, is, oh, but my IDE does this. And it's true. Most good IDEs will have plugins, will tell you a lot about these things. You will get little red squiggly lines saying, oh, this isn't defined, this isn't imported, and so on. But it doesn't necessarily give you everything. As one example, I use IntelliJ with the Python plugin, and I use version 12, and it doesn't warn me about the dangerous default argument that you get on the first slide. So it turns out newer versions do. Someone corrected me when I gave this talk at EuroPython that actually IntelliJ now does do this, but at least in my experience it didn't. And that's just one example. You don't necessarily get every single possible warning just from your IDE. And also, you don't necessarily check every single file in the you don't check every single file in the project when you change something. So if you refactor a method or you rename it, you don't necessarily have every file checked by your IDE. So again, a global tool is quite useful. Yeah, and your IDE doesn't check other people's code is kind of other people aren't necessarily as fastidious as you are, so it's quite nice to have a centralized place where you can kind of see if everyone is actually sticking to style guides and quality guidelines and that kind of thing. So how do you actually get the most out of it? Well, in a magical world where you start a new project from zero, then you can start right at the beginning and keep track of it. This is not necessarily, or not very often possible, and you're trying to retrofit this onto an existing thing. So step one is to understand what these tools are giving you. It's not, if you treat the output of these tools as gospel, then that's the sort of path to misery. You're going to end up hating them because they're going to give you lots of picky things that you don't agree with. What you should really think of is this is a list of suggestions, or it's sort of like a code review or someone looking over your shoulder and going, is this correct? Are you sure? Could you maybe just take another look at that? And you can choose to ignore it or not, but don't treat the output as, sort of this is 100% correct. And the second thing is, it is worthwhile, and at the very, very beginning it might seem a little bit unnecessary, or you don't want to spend the time tuning the tools, but it is actually worth it in the end. And then the last point is to measure and track over time. So this comes back to the first point, where the tools are not infallible. They will give you things that you don't care about. The general idea is they are at least consistent. So if you keep track of the number of errors you have, if that's going down, then you're doing well. You're improving your code. You don't necessarily need it to be zero. You just need it to be less than yesterday. So we find it quite useful to have, there's a Jenkins plugin that has a Pylint plugin for Jenkins that has a little graph that shows you over your build if the number of errors that go up or down. And it's a little bit shonky, but it works. You can also hack something together yourself. If you have a Graphite or InfluxDB, you can send metrics to it and then get the graphs yourself. Or at the very least, just do pipe the output into word count and keep track of that number over time. This is another problem that I wanted to solve with Landscape, is the immediate output of tools is not necessarily the most important thing. It's more about the changes in what you're doing over time. So are you improving your code over time is more important than how good is your code right now. So when it comes to tuning, there are, well, I think on the slide I showed, I think there are about 9 tools, and there's several that I didn't include. They all do things their own way. There is no standard. So you do have to kind of dig into the documentation a little bit and kind of figure out whatever runes you need to turn off or turn on or tweak each tool individually, which sounds like a pain in the ass, and it is, but ultimately it is worth it. The amount of time that you put in doing it is maybe, say, 1 day up front, but it will probably save you a day over the course of the next year, because your output is actually meaningful and you care about it, so you actually look at it. If you don't do this tuning, then you get a whole bunch of stuff you don't care about, and the tool sort of becomes useless because you don't want to look at the data. You don't want to look at the output. The second, more involved way of doing things is to write plugins. Especially Pylint has a not brilliantly documented plugin mechanism. So one thing I did, a long time ago, was I was a little frustrated that when you run Pylint on a Django project, it will give you lots of errors that are not errors. So for example, you have a model, and that model has a .objects, which is how you access all the, how you do the ORM queries, for those of you not familiar with Django. The thing is, that sort of magically springs into life as part of the meta-programming of Django. So Pylint looks at the code and says, oh, it doesn't have a .objects. And you get hundreds of errors all over your code saying .objects does not exist. And you think, well, yes, it does. I know it does. So one thing I did was I wrote this Pylint Django plugin to turn off and tweak and essentially alter the behavior of Pylint so it doesn't warn you about Django-specific things. And also add a couple of additional warnings that are, sort of Django-lint, you could almost say. So that was a bit more involved, but it's definitely worth it. If you're using a library that gives you thousands of errors, then maybe it's worth looking into a Pylint plugin that can tweak the behavior of Pylint to actually adapt and fit to the code that you're using. If you don't care about all that stuff, then you could use Prospector, which is another tool that came out of Landscape. And what that is essentially, it runs lots of tools for you, and I tried to make it kind of easy to get up and running. So the biggest complaint that people often have is, number one, the output is spurious and they don't care about lots of the problems, and number two, there's too much of it. So what I wanted to do was write something that brings all the tools together, gives a kind of consistent interface for running and sort of tweaking configuration, and gives you nice out-of-the-box settings, so a kind of static analysis for humans, if you will. What it does is detects that you're running Django and installs the Django Pylint plugin. It turns off a whole bunch of really picky errors that people often don't care about. It gives you sort of high-level strictness, so you can say strictness high, strictness medium, all that kind of stuff. So what it's trying to do is solve all the problems that I just talked about that people don't really want to dig into Pylint. They don't want to dig into all these tools. They don't want to spend the effort. And it's not a replacement, because you can't, it doesn't have the same power as the other things in terms of configurability. But the idea is that it's a sort of gateway drug that gets you started, and then if you decide that you need the extra power, that you can then dig into the tools and start doing things yourself. The ideal situation with Prospector is that you download it and you install it and you type Prospector and it gives you something useful straight away, thus trying to solve the problems that the other tools have. And yeah, so okay, I've gone a lot faster than I expected, again, but never mind. So these are just a little summary at the end. Is basically, you'd be surprised how useful it is. And actually one thing that Measure and Track gives you is that you can see how useful it is. You can actually see if it is giving you any sort of benefits, and it really does help. The amount of errors you pick up before they sort of get into your production system is non-trivial, and the amount of things you learn is non-zero, and because it's basically free, if you already have a CI sub, you may as well do it. But the way to get the most out of it is to keep track of metrics and compare things and see if you are improving and see if you're changing things. And yeah, incremental improvement is the best way. The most important thing is that the current status is not important. Is it better than yesterday? and you should use AnswerPy. So this is the big list of things. The one at the top is carlcrowler.com/PyCon UK, where you can get these slides, and the list of all the links is on there too. So you don't need to sort of try and write down all this stuff. You can just get that from our website. And yeah, so that's it. I will stand here for 5 minutes until the end of my time.
So where does Landscape.io, how do they feel about the latest news about things like optional typing and stuff like that? Do they plan to roll that into the tools available to do checking, or what's their take on that whole situation?
I don't really know. The guys who do IntelliJ released a thing recently called Python Skeletons, and as far as I can tell, it's essentially a separate project that annotates the types of the standard library and various other libraries. I'm not sure if it's on this list, but yeah, if you search for Python Skeletons. So that's one approach. I think it's an approach that the JavaScript community takes for doing linting, and sort of type annotation is a separate thing rather than being part of the code. I know the Pylint guys are basically, they're rolling out a whole bunch of other architectural things first. They need to figure out how to do, if you run Pylint using Python 2, then you only get Python 2 checks. They want to do a sort of, can you check Python 3 from Python 2 and the other way around? And there's another thing they were doing about confidence levels. So how confident am I that this is actually an error? Because there are a few things where you have to sort of guess. So I think there's a lot of other priorities first that are going to come out before anyone starts integrating those. Do you need those?
I would like to add one thing, the list until frosted. You can easily use them with Syntastic in Vim. You only install the tools, you install Syntastic, and everything works magically.
There you go. So.
Were there any more surprising statistics that you found doing your analysis of all these open source projects?
Not yet. I do have a gigantic JSON file on this that I want to kind of start digging into and really trying to find things. One thing I'd like to figure out is, well, so the problem I have is that the majority of the errors that Pylint pops up are this thing doesn't exist, but actually statistically that's not true. Like it's almost always because a requirement is not installed or something like that. So I'm working through kind of filtering out a lot of this stuff before I can really make some interesting observations, unfortunately. If anybody wants the data, by the way, I can provide it. Just drop me an email and I can kind of provide you a JSON of the output of the Pylint checks of all the open source repositories, if you want to do any sort of data analysis on it.
Another round of applause.